Welcome back to another version of EL 164. This is the lab portion of Chapter 10 and 15, Chapter 15, Part 3. Today we're going to be discussing data manipulation instructions, the lab portion of this lecture. Okay, so today we're going to deal with data manipulation. So first thing I'm going to do is, as always, I create a new file. I'm going to call this new file data manipulation. As always, I have 0 expansion modules. Zip through this here. Next thing I'm going to do is I'm going to create my my tags over here. So I'm going to go over here, create some tags. Tag. How about I'll start with double integers today. Those. Create, keep open. How about some binary? I call this Boolean. Create, keep open. How about some integers? Create, keep open. How about some counters? Create and open new. Okay, and then last but not least, let's put some timers in there. Okay, got that in there. I'm going to hit create that. Go back here and make sure I got everything I need. I got 10 counters, 10 timers, 10 integers. It's like I screwed up on the Boolean. I'm going to come down here, go edit. I'm going to go over here, Boolean, click on this guy, put in a 1 here. Hit OK for that, and that's going to give me what? 32 bits again. So now I got 10, 32, 10, 10, and 10. That's exactly what I'm looking for. Perfect. Okay, I got all the information into my tags. I'm going to go ahead and download now. Download. And something didn't go right. Empty rung. Okay, so we got problems. So I got to put some logic in here. For today's lab, I've got a use a normally open, one normally closed push button, an output light, and then we're going to do some move functions. Move an A into a output word when it's on, and move a 5 into the output word when it's off. Okay, as you can see here, I've created the seal-in logic, or the start-stop program, using an internal binary. Next, I need to add the move statement. So you'll see exactly what I got going on here. I'll bring you through this whole step process here. So first thing I'm going to do is grab a rung, create a new rung. I'm going to come in here and say, so the first piece is when it's on. So when this bit comes on, I drop it in here. And then I want to come over here to the move function. Move is over here, so I grab the MOV. And I'm going to grab this information here, drop it in right there. Oop. For some reason it doesn't want to go today. Source 1, we're going to just grab, I can put a register, I can make a register here, I can put a value in here. So I'm going to do, first thing I'm going to do is I asked for a hex value, so I'm going to go pound, I did that backwards, 16 £, A for the first value. I like that caps. And then I'm going to dump this right into the output data word. So I'm going to come over here, data word. I'm going to dump it to the whole word, not one bit, but the whole word, all 16 bits of that output word. Now I'm going to duplicate this. The easiest way to create logic is by copying it. So I'm going to go ahead and copy it, paste it here. So what I'm going to do is here is I'm going to make sure that it's on the off state. So I'm going to go XIO. So when this bit's off, it's going to turn this on. And in the off state, I want to put a 5 in there. So as we all know, 5 hex is the same as 5 decimal, but I put in there as 5 hex just so we understand that we can create a hex value, and it doesn't have to be in an A, B, C, D, E, or F form. So in a 5, it can still be read as a 5 in hex, which is obviously the same thing as decimal. It is at this time I will download. Okay, now I've downloaded the program, so it's all ready to rock and roll here. We're going to make things happen here. I'm going to go ahead and turn on the sealing circuit, and we should see a value of 5. Oh, you know what? Dinkers, I'm not in run mode. Let's get this thing in run mode here. Okay, so now we're in run mode. We got run mode, we're controller okay, we're IO okay. Is okay. So I've got putting a 5 into my output data table because this is off. So if I turn this on, I go here and hit this button to turn it on. Binary 0. I grabbed the wrong one. All right, hold on here. Let's do some online editing here. That's a good opportunity to do some of that. So we come in here. Go over here. I don't know how that took place, but somehow it decided it was going to change my input on me. Accept the edits. Yes. Okay. So now I'm going to press this button, and this output turns on, or this light, this binary bit turns on, sealing it in. And it turns this guy on, which is now setting this register to what? Let's take a look here. If we can zoom in on this guy a little bit. There we go. By hitting the control and the wheel on the mouse, I'm able to zoom in and zoom out on this. So as you can see, by doing so, now I have a value of A in my output data. So if you are looking at my controller as I am seeing it now, we will see the 1010 in my lights. When I turn this off with this button here, I end up with a 0101 now in my outputs. So to better illustrate how this is taking place, I'm going to flip it back and forth a couple times so everybody can gather what's going on there. So when this guy is in the off state, we're going to be moving a 5 into that location. And when it goes to the on state, we're moving an A. So I flip it back and forth a couple times here just to make sure everybody understands what's going on. So I'm moving a 5 in there, and I'm moving an A in there. 5, an A. See how it's flipping back and forth. Okay, that completes part 2. This would be the first sign-off had we had online lecture, but unfortunately we are still on a remote location here. So what we're going to do is we're going to move on to part 3 here, following the lab. Here we're going to develop a program using a mass move using a subroutine called MVM, or mass move subroutine. So first thing I'm going to do is I'm going to go in here, I'm going to create a new subroutine. Let's go ahead and go offline. New routine, I'm going to call this MVM. MVM. See, MVM showed up here. So next thing I'm going to do is I'm going to come in here, I'm going to create a new rung here. And what do we got to do? I got to go to what? I got to go to program control. Remember this from last class period. Program control is where I find what? JSR, jump subroutine. Here I'm going to select here. I'm going to go find MVM. And I'm going to come in here, and then remember before we had to remove instruction parameters. So I'm going to go ahead and remove instruction parameters. Now as there's no more E's here, I'm going to go ahead and download this information. So now all of a sudden I'll have my MVM populated and running. Okay, I downloaded that. I'm over here. I'm going to switch over to MVM, my new subroutine. And now I'm going to create some logic to incorporate this mask move. So how are we going to go about doing that? First thing, we got to develop a program to using a mask move. So what we're going to do here is we already created a new rung. I'm going to go over here to favorites. Let's just put a push button in front of that. Say I've already used 0, so let's see here. We're going to grab 1. Next push button over. And then I want to do a mask move. Where do I find that? Under move logical. That's that MVM here. So the first thing it notes here is I have to come up with an integer 0 for my source. So I come in here, I got to find what integer 0. It says here I want to use the mask, set the mask to the digital input word. So where are they going to find that? Where do we find that? We find that right under here. Digital input word, digital 1 data, right there. That's what we want right there, the whole word. We're going to use that input information from the push buttons and toggle switches to create the mask. Kind of a cool idea. And then we come out of here and we're going to be writing this to integer 1, just integer 1. So we come in here, integer 1. Now why are we using integers? Why do you think that is? For those of you that are not so sure, I'll review that real quick. Integer is what? 16 bits long. How many inputs do we have associated to this processor? 16 bits. So what I'm comparing and moving and all this sort of thing, I'm moving information, mask moving this with 16 bits. So I got 16 bits of my source, 16 bits of my mask, 16 bits of my destination. This is kind of critical. We can't move information. Sometimes Algebra lets us get away with it, but not always. So we got to just be aware that we got to have the same number of bits that we're manipulating in these blocks. That otherwise it gives us some errors when we try to do that very thing. So as you can see, I got some eyes over here. That means I'm doing what? Online editing. So let's go ahead and finalize these edits. See what happens here. Hey, it seemed to like it all right. All right, now we've got the mask moving. I went ahead and filled in these registers. The first, the source is an F081. The local is the input data word. I switched all these to read in binary so it would help understand what was going on here. And then the last piece is the integer 1. I went ahead and put a clear register rung in here as well, a separate input, so we can get a better understanding of how this mask actually takes place. As you can see now, I have actually triggered it once with the 8, input 8, and I have the value of what? 8000 in there. So as you can see, I've got that there. So if I hit this I9, it zeroes it back out again. So what I'm trying to illustrate here is that when I have the value of this one here and this one here, as you can see, you add all these components together and you end up with all zeros. So if I take this guy here and turn him off, and I trigger this, we should still have a 0. So let's see if I hit number 8, I should see all zeros in the destination. This is coming on and all zeros. As you can see, we're lining all these bits up one next to each other. You'd see it's an and, a 1 0. A 1 0 and is always going to be what? 0. So when I come back through here and I create one of these inputs and turn them on that will be aligned with something like this, see, I turn on bit number 16. So I got this guy on here. When I trigger this guy here, it will come to be true down here. Awesome, excellent. So now you can see that mask only allows where there's a 1 through to the next segment here, into this integer 1. If I take away that mask, that number 16-bit, and so now that bit is masked out, and I trigger this MVM again, what do you think is going to happen? Do you think it's going to zero that out? Is it going to move a 0 in that location, or is it going to keep it a 1? Now it's masked. It's not going to transfer any information to this location now because it is masked. Watch this here. Triggered, no change in state. It still stays a 1. Now what I have to do is I got to come over here and clear that word with a 9. And you see I drop that out of 0. That comes on. That makes that 0. And now if I hit the 8 again, you will see it keeps it as a 0. So keep that in mind. When you're masking something, you're masking not only the 1s, but the 0s as well. So you're not letting anything through to this mask. So whether it is a 1 or 0 up here, if it is masked out, if it's a 0 here, it is not coming through to this point here. And then I'll illustrate here how I can turn on a few more bits here. So I've got all these bits here on, and then if I go ahead and, I got 9 on as well, so I turn off 9, we will see what? We'll see wherever there's a 1, we're bringing it through. And then these are all 0s, here's a 1 here, but there's no 1 in that location. And that's pretty much how that plays through. Let's see what happens when I turn on this one here, which is going to be bit number 8. Oh, I don't have a bit number 8. I only have a bit number 7. So let's turn on bit number 1 and see what happens there. Bit number 1 and bit number 1. With this in place, you should see that come on. So here we are. We saw when I close this, it sees a 1 here, brings a 1 here, brings a 1 through. We turn it back off. It stays a 1. Why? Because now it's masked. It's moving, but because it's a 0, it's not moving that information to this location anymore. The only way I can clear that register now is by taking this and turning him on, clearing him out, and then coming in here. And if I trigger him again, you will see at that point it is cleared out. So that is part 3 of the lab, where we mass move some information from one location to another, keeping in mind that mask ignores wherever there's a 0 to the destination. So whatever's in the destination has to be manipulated either externally from that, or if you're changing that mask, or you have to utilize the source information to manipulate that destination data and keep the mask the same. Typically, in most applications, you'll see the mask not change. Usually you set the mask to 1 number, and then you're feeding data through the source, and that data in the source is being transferred through the mask, depending on what bits you want to in particular that you want to manipulate. Okay, so now we are on to the next section, next piece of this, step number 4. Here we're going to use develop a program using the file copy command. Again, what I want to do is get in the habit of creating subroutines, so I'm going to go ahead and create another subroutine for this application. So I'm going to walk you guys through that one more time. New routine, come in here, type in copy. Copy. So now I've got the copy routine here. I'm going to go in here. I can do this right while we're in run mode, I believe. So let's see about adding another rung here. So add a rung. And we're going to do a copy command here, or a jump subroutine. So we're going to do a file miscellaneous. Oh, no, it was program. It was no. It was program control, JSR, jump subroutine. I'm going to come in here, type, I want to find copy, right there it is. And then again, we got to go through here and remove instruction parameters. Okay, so now we've got that. At that point, we can accept that and send that to the processor. So now we are calling the copy command. So now this copy command is being called. So now we can move into the next process, developing the code for this. Okay, now we're going to create a copy command. We got a new run created here. So let's go ahead and grab some favorites here. Let's go here, favorites, grab a contact. Come over here to move logical and file miscellaneous copy. There it is, file miscellaneous copy. We'll grab that guy right there. And then we'll come over here, put an address on this location here. We'll just stick with that same input we've been using, so that works there. Let's start PB. How about we go selector switch so I can leave it on. And then here we're going to grab a source file. This time we're going to do double integers. So I want to grab a source file, say from double integer 0. And I want to put that in to say, how about a counter? A counter value, wait a minute, I can do multiple counters here. Why don't I do it this way? Why don't I do a double integer? Better yet, why don't I create another word? That's what I'll do. New tag, call this copy destination. I will go here, got double, it's already a double integer, that's good there. And I want to create, say, 10 of these as well. Go ahead and create that. So then I'm going to come in here. I want to have this guy be double copy destination. Total 10 of those. So now I can do, excuse me, I can do 10 words of this information. So I'm going to grab 10 double integer zeros here. So I see here I've got, as we've done in the past, we've created 10 of each. I've got 0 through 9 here. And I'm going to copy destination is going to have 0 through 9 here. So when I say I want to do 10 registers of information, I'm going to be copying all 10 of those. So let's take a look and see how that responds to it. I'm going to populate each one of those registers with a number. Okay, as you can see here, I've set up some of this so you didn't have to watch me set all this up. Input 8 is feeding the copy command, file copy command. The source is double integer 0. The destination is copy destination 0. That means that we're going to be pulling all these words, each one of these 32-bit words, excuse me, are going to be transferred to this location here. All right, at this time, I'm going to go ahead and populate this information here. Okay, now I've got this populated. I'm going to go ahead and download this information. So at this very moment, you guys can see double integer 0 through 9 has got 0 through 10, or 1 through 10, excuse me, 1 through 10. At this very moment, also, we do not have anything populated here in copy destination 0 through 9, all zeros. So we're going to go to the logic here, copy command over here. I'm going to close this command here, close this contact here, and we're going to see the information populated, and I should be able to visually see this in all these move statements as well, but let's see what happens here. Hit the command. We come in here, we hit this guy. As you can see already, I have 0 through 10 populated in these statements here. We'll go to this tags, and look at there. It's a complete copy. Copied all 10 words from this location to this location. So the reason I had to put those moves in there is I had to move a 0 to each one of those locations, right? I can move one word in a move statement. I can move one source to one destination. So I'm moving this 0 to this location. So I'm going to hit this I9 now. See, I8 is off. I'm going to hit I9. And you're going to see what? They zero all those registers out. So we'll go back to the tags here. And you can see they're back to 0. If I hit I8 while we're in this screen, you will see it populate just like so. If I hit I9 here, you'll see it go back to 0. So this is where watching the data table really comes in handy when you've got to look at multiple locations at the same time. Where we can notice we can always see only about a few of these rungs or a few of these move statements at a time. So if there's multiple rungs of logic we're trying to manipulate and monitor, by going to the tags, we're able to do that very thing. We can sit here and watch these bits here. We'll know when they get moved in, and we know when they get cleared. So kind of a handy little feature that data table is. All right, so that's how the copy command works. We basically take 10 of these registers here, and we're copying them to 10 of these locations here. It has to be continuous. It has to be you can skip 1, 2, and 3. It has to go 0 through 9 because we selected 10, or if we had 15, it'd be 0 through 14. Excuse me. However, it's set up like that. So it's a continuous flow of registers. It's not pick and choose between them. It takes the whole series of registers 0 through 9 in this case, and it drops them in 0 through 9 in the copy destination. Now, as you can see here on the bottom of this, to clear this, I set up a whole bunch of moves. My reason behind this is to give you a feel. Okay, there's a lot of work that can require to reset a register or something like this. So I mean, you can see I went through the trouble of making these individual moves, so you get an understanding of how much work it can be to do this. When we look at the next command here, you'll see exactly how handy it is to do what they call the file fill, which is step number 5. We're going to move into that. Okay, as you can see here, I have the JSR for the FFL created, and I created the subroutine FLL, for file fill. So we're going to go ahead and populate file fill with some good information here. All right, so for this command, I'm going to take and I'm going to eliminate, using this command, I want to eliminate these move commands that I placed here in the previous, in the copy command. So what I'm going to do is here, I'm going to go in here, we're going to create a series of contacts and whatnot here. Let's start with the favorites, create a contact. We'll go in here and grab that same input we've been using. So local 1 data, first toggle switch works pretty well. Then we're going to come over here, we're going to go to file, manipulate file, miscellaneous, FLL, file fill. Here this time we're going to grab a source value. See, I can put a source value of just put 0 in here. I want to just put 0 wherever I have information that I don't want to have information. And what we're going to do is we're going to 0 out that destination, that copy destination location. So I'm going to come in here. I'm going to go copy destination 0, a length of 10. Oh, wait a minute. When I go to copy destination, I think if I do 8, I'm going to have trouble there. Let's see here. I better go 10. Let's go to 10. Okay, we're going to accept that one there. Yes, here. Okay, so now let's see how this guy works. So we're going to come in here. We're going to hit the go back to copy. We're going to hit this 8 again. So we're going to populate the copy destination with information. So I'm going to hit 8. Go back to copy. Hit this 8. And we're going to see This information populated. Oh, destination. Uh-oh, I might have something on already. Hold on, let's see what we got going on here. 10 is on. Let's turn 10 off. Can't put anything in there if it's zeroed already. So let's try that again. I'm going to hit 8. And there it is. Copy destination has been populated. We go over to file fill, the FLL. We're going to trigger this command. And then we're going to go back to the tags and see what we got there. We zeroed them all out. So all 10 of those registers are cleared out by using one command versus using 10 commands. A much more efficient way of handling that situation. I gotta believe you agree with this. So instead of creating 10 rungs of moves like I have over here, which does the very same thing, I can do the same thing with one function that does that same operation, that moves zeros to all those locations. Now I could have grabbed something I could have grabbed another file here. So let's go ahead and fool around a little bit. Pending edits. Let's grab something like I want to move the counters accumulator to that location. Accept that edit. Now the counters accumulation zeros, counter 0 is going to, the accumulator and counter 0, excuse me, is going to be set to 0 at this point, I believe, because I have not created any counters at this point. But we'll validate that. Okay, so counters accumulation at this point is 0. So let's say I want to make it something other than 0. I want to make that, say, a count of 50. Say we've counted to 50. We reach that count. We want to populate that information to all 10 registers. I'm getting crazy with the count. Flicking here. Clicking, clicking, clicking. Okay, all right, now, when I press that button over here on File Fill, instead of moving 0 to that location, it's going to move what? It's going to move 50 into that location. Let's see what happens here. Click on number 10 here. Let's go back to tags. And what do we got? We filled it full of 50s. So just to give you a feel, it's a pretty handy little command. It gets fills up a lot of registers with the with information. Gives you the ability to manipulate multiple registers from one location. Pretty handy little tool. Like I used it before is moving zeros into there. It works really handy when you got to clear a large file or a large series of words to a 0, back to 0 again. So works pretty well for that. So that is how the FLL works. Essentially, one source, multiple destinations. Think of it as dispersing the information from this location to multiple locations. We're on section 6 now, or part 6 of this. Probably the most demanding of all of them as far as well, the pieces that we're incorporating, but I think you'll get a pretty good handle on what we're trying to do here. We're going to try to use all the different compare instructions in one rung of logic. So I'm going to develop a few pieces of these so you don't have to sit and watch me develop a bunch of code. So I'm going to pause it for a quick second. Okay, as you can see here, the first part of this I had incorporated a flasher circuit. So the flasher circuit, as we learned in the previous lab, is set up. And all I'm doing is sitting here setting it up with a counter. So the counter is actually counting up, as you can see. And I just set preset to 5,000, some random number that was really high that I didn't want it to impact the operation of my program here. Next piece of this is I got to start setting up some of these compare instructions. So again, I'm going to pause the program a little bit here so you don't have to watch me go through. I'll tell you what I'll do. I'll go to the first one first. So I'll go ahead and go offline here. So where do we find the compares? Right here under compare. So I got to come here, create a new rung. I got my compare here. First one we have is we're going to use a limit. The CMP is available. I'm going to kind of skip over that. I'm going to skip over the mask equal to something. A couple pieces of this you don't use a ton of, so I thought I would focus on the points that we use the most. So I thought this would be a good spot to throw some of that in. So the first limit we have to deal with is turn the light on when the value of the counter is in the range of 5 and 6. So the high range of this is what? Excuse me, low range of this is going to be what? The 5. Let's see, the 5 and 6. Oh, I meant 4 and 6. I'm sorry, I meant 4 and 6. We're going to be testing the counter 0. So come over here, go to counters. Counter 0, accumulated value. That's this value here, the accumulated value. It's at 0 at this moment. And then the high limit is going to be 4 and 6. So we got 6 here. Okay, so when we see the value of 4, 5, or 6, we want to do what? We want to turn on light 1. So we're going to turn on our first light. So I'm going to come back over here to favorites, turn on our output, switch this to our output here. And that's going to be under output data. My first light is under 0. So there's my first limit. I'm going to go ahead and I'll keep pulling a couple of these from comparison, and then we'll be discussing them here real quick. Oh, break it in again. We got this limit here. What I can do is, again, copy this. It's a lot easier to copy than it is to create. So I'm going to copy this rung. I'm going to paste this rung here. And here I want to flip-flop the ranges. So I want this to be a 6. And I want this to be a 4. Because what we're going to do is we're going to look for the numbers that are outside the range between 6 and 4. Remember we talked about that in lecture. This is looking for inside the range of 4 to 6. This is looking outside the range between 4 and 6. So any number outside of 4 and 6 will turn this output on. So we're going to turn this on output 1. Okay, next one I'm going to include is the equal. I'm going to come in here, grab a rung here, throw in the equal. That's not equal there. So what I'm saying here is, again, is the value is the counter value, counter 0, accumulator, equal to, this is equal to 6. Equal to 6, we turn on an output. Oh, what happened there? I must have screwed up. We turn on output number 3, light number 3. Next one is a less than or equal to. So again, I come over here, create a rung, come in and throw this in there, and then do the compare, and then less than or equal to. Oh, I don't need contact here. What was I thinking? I need, so looking at the source, is again going to be that counter. I can grab this guy here, drag him right in there. How do I do that? I can. Yeah, just like that. Yep. And this has got to be greater than or equal to, or less than or equal to 5. And this is the output is to be output 5. I think I missed one here. I got to go back and add one here. This is 5. I'm going to insert a rung here. I forgot not equal to. So let's grab compare, not equal to. Oh, I'm going to grab him again. Not equal to 0. And it's going to turn on output. I want to do this. There we go. 5, and then so when this guy's not equal to 0, it's going to turn him on. When this guy is less than or equal to 5, it's going to turn this guy on. And we got one more to do, is greater than or equal to. So let's do that one. Greater than or equal to. Again, I'm using the same counter again. ACC. Greater than or equal to 10. We want to reset the counter. Okay, so where do we find that? Under counter, reset. And that counter is the same counter here. But as you can see, it got way up here. I don't want to copy instructions. I'm just going to type it in here. Okay, so now when we reach the value of 10, we should reset our counter back to 0 again. So let's see how this whole thing plays out. Let's download this whole thing. As you can probably hear, I've got a whole bunch of clicking relays here. So what exactly is taking place here? So we can see here, this guy here is clicking on when he's in the range of 4 to 6. Kicks on when it's above 4, or it reaches 4, and stays on until it hits 6. So 4 turns on, 5, 6 turns off after 6. So this guy here, he's reading anything outside of 4 and 6. So it's 5, 6, 7, 8, 9, 10. Oh, I must have something going on here. Hold on here. I know what I got going on. I got multiple rungs being called here. Let's go to main. Yeah, I got some outputs being called from other areas. Just shut this down here. I'm going to go ahead. Okay, so now we've got our limits in. So now we're going to evaluate how these all work. So what we're looking at here is I got a flasher circuit flashing up and down. And then I got a counter counting from basically counting to 10 every half second. As you can see here, I'm back to well, it skips 10 because of the way we're setting it up, but you'll see why here in a second. So the first piece of this I wanted to look at is evaluate how this is taking place. So we come in, this guy here turns on when we reach the value of what, 4, and turns off when we reach the value of what, 7. Now this one's this is the outside the limit area, because the low limit is higher than the high limit. We talked about this in lecture. Watch how this one responds. So when the value of this guy reaches what, 5, it turns off, but it turns back on as soon as it reaches 6. So it's the value between 4 and 6 that it turns off in. So keep that in mind. That may get you on the exam or something. So make sure you're aware when this guy turns off. 5 is the only number it turns off at. So this might get you. So be careful. This is one to pay close attention to. All right, next piece of this is equal statement. As you'd expect, it only turns on when this value here is equal to 6. 4, 6, clicks on, drops back off at 7. Not equal, as you would anticipate, it actually does click off, or excuse me, when it is equal to 0, but it's happening so fast that we're not seeing it. So what I'm going to do next is I'm going to come in here. I'm going to put a little delay in here. What's this? Let's see here. It's going to get it to 10, but that's not going to get it to 0. Let's do this. Not equal to, I gotta go here. How about I say not equal to 1? That way we can actually see it. That's even better yet. That way I don't have to fool around with that logic and we can get through this a little faster. So now you're going to see when this is not equal to 1, it's on, and when it is equal to 1, it's off. So we're not having to mess with logic. You can see as soon as it turns to 1, it turns off. So keep that in mind. Not equal means it's on except for when the two match. The next piece is less than or equal to. Again, you'll see here, what you'll see here is that this guy's going to say less than, so it's less than 5, all the way up to it reaches 6. So it stays on until it reaches the value of 6. And then the greater than. You'll see here what I've got here. As soon as this reaches the value of 10, we're reaching the value of 10 and dropping it out. So if I came in here and I put another contact in here, say just grab some random input maybe. And then I turn him off. You're going to see this guy count to 10, 11, 12, right on past 10, right? And then as soon as I click him on, because this value is greater than 10, we're going to reset that counter. Right back to 0 again. So counting right back up again. So that is the commands here. A lot of these are relatively intuitive. Just don't let them trip you up because there's a little bit of tricks to a few of them. The limit one is definitely a tricky one because it uses the value 4 and 6 when you have the low limit and the high limit in the proper place. But when you flip them, it's using the values outside that range. So it's got, like in this particular case, if you're looking at this, the only time this is going to turn off is when it's equal to what? 5. So there you go. So that's how that works. So that is today's lab, or this week's lab, for the data manipulation instructions. Hope you guys are all doing well. I hope things are going well for you. I've been seeing some population of the Unit 3 stuff. All online stuff's coming together for you guys. I see getting better and better. Make sure you're submitting everything through Blackboard. I'm getting so many emails now that I can't distinguish students from faculty or other faculty, and I'm getting too much information, and I can't manipulate all that information. If it doesn't show up in Blackboard, I'm not going to grade it. So make sure you can get it into Blackboard. If you can't get it into Blackboard, let me know. Say, hey, I'm missing some information. I don't know where to put it. I don't know anything of this nature. I do have a video in Blackboard called Blackboard Help to give you some kind of indicator on how to upload your files into Blackboard. So again, if you have any problems with that, give me a shout here. I'm on email quite regularly now, so I'll be talking to you soon. Adios. Bye-bye.